Any questions on 2A? Anything at all? All right, let's move to 2. You do that on your own. Let's see what you got. What shape? X, x squared, x cubed, 1 over x, square root x, a to power x, log x, absolute value x. Which one? Base function would be what?
Absolute.
Good. All right, figure out what changes we're making to it. Here, f of x equals. What has happened to it? Remember, the original shape for absolute value is what? It's the V shape. So it's like here, here, here. So that's the basic shape, and we are going here.
2 down.
Yeah, very good. Did you say 2 down?
Yes, ma'am.
All right.
1,
So
2. No, -2. -1, -2 down.
yeah, so
Right.
2 down, yep. So 2 down means subtract 2. And
Okay.
so 2 down, but also left so much. How much left?
1.
1. So 1 goes in here then. So let's see, somebody raised their hand, I think. Stephen?
Big Steve.
Steve?
Yeah, so I have like 40 screens loaded up, and I can like see your cursor moving very, very little. I was wondering if there was a way to like blow up the screen you were using, or if I'm doing something wrong.
No, actually, hold on. Let me see if I can shut some of these documents. Okay, what about now? I blew my screen up.
It's still showing me kind of the same thing. It's like 4 million screens in one.
4
If that
million.
makes sense.
Yeah, it actually does. So let me see. Like this? Like whole bunch of one screen behind another, right?
Correct. Yeah, it's just like continuously opening itself.
Yeah. Okay.
Oh.
All right. Now what do you see now?
I see 4 people and you.
Yeah. Okay. Okay. Now. Okay. Now what? What do you see?
Oh, that works.
Okay. All right.
Back in the game. Thank you.
Okay. Good. Good. Yeah. You have to speak up, otherwise I don't know what you see. I only see what I see. Okay. So the question was, so this was the original shape, and we made left 1 and down 2. And so that's why left 1, so that's not -1, but +1. +1 will take it left 1, -2 will take it down 2. Everybody okay with that? Yes, no, something?
Yes, ma'am.
All right.
Yeah.
Okay. All right, what about this shape? What shape? X, x squared, x cubed, 1 over x, square root x, a to power x, log x. What do you see?
It's like the first one.
Log X.
Log, very good. What base?
Yeah.
So you'll have to think about how to, so let's put that here. You'll have to figure out what the a is. So this is going to be log function is our base function. And you'll have to figure out what the a is. So look, when x is 2, your y coordinate is 4. When x is 4, y coordinate is 5. When x is 8, y coordinate is 6. So figure out what log function will do that. What do you think? So we know it's log of something, but log of what? What base you want to try? You can try it, and if it doesn't work, we pick a different base. Let's try what? What do you want to try?
2.
All right, 2. So when x is 2, Here right now you will get log base 2 of 2 is 1. So then you would have to do plus something, plus 2 or something, or plus 3. Let's see if that works then. So log, if I plug in a 2 here, this will give me 1. 1 plus 3 is 4. Oh, who said the log base 2? That was awesome. If you, yeah, very nice. All right, what if you plug in 4 here? If you plug in 4, log 4 base 2 is 2. 2 plus 3 is 5. Look at that. You got it. And if you plug in 8, log 8 base 2 is 3. 3 plus 3 is 6. So that works. So there's your function then. This is a good exam question because you have to figure out what the base function is and how to make it work. Everybody okay with that? Any questions here?
Can you repeat what you said, please?
Yeah. So let me open up a
This
little
one, C.
text box and put that here. All right, so what we're saying is that if this was, oops, that if we replace the x with a 2, then this will become 1 plus 3 or 4. Can you see why this is 1? How do you evaluate log of something? It's 2 to the 1 power is 2, right? Do you remember how to evaluate logs? And if you plug in 4, so 2 to what power gives you 4? That would be 2. And 2 plus 3 gives me 5. Can you see? If I plug in 8, 2 to the 3rd power will give me 8, and 3 plus 3 gives me 6. So it matches the coordinates here, 2, 4, 4, 5, 8, 6. So 2 and 4, 4 and 5, 8 and 6. Can you see how the points match up? Gold?
I'm trying to get it.
So you need to remember, it may be a while since you saw logs. So let's make sure you know how to evaluate logs.
2, 4, 8. Okay.
So if I want log of, say, 16, how do you evaluate it? You're looking for what? You're looking for 2 to what power gives you 16?
Is that 4?
Yep. So this answer would be 4. So if I wanted log 2 base 2, you're looking for 2 to what power gives me 2? That'll be 1.
2, yeah, 1.
2 to what power gives me 4? 2 to what power gives me 4? Gold?
Okay.
Yep, you
2.
see? 2.
Yes, ma'am.
And then what about 8?
3.
3. You see how they're evaluating it?
Yes, I did.
Yep.
I want to.
And so the only way you're going to get 6 is if you added a 3 to it.
Okay.
So that's how we know that our equation is going to be y equals log x base 2 plus 3. You okay with that?
Yeah, I'm writing it down.
Yeah. Anybody else has question on that?
It's fine.
So I'm going to do a little teeny, oops. Uh-oh, sorry. All right, sorry. You got it?
Okay, so the last one now.
Yeah.
Yes, ma'am. I thank you.
You got it? Okay. All right, let's do D on your own. Figure out what D is. What shape?
Oh, shit, she did this yesterday.
Yeah. What shape? X, x squared. Which one?
X to the third power.
Yes, very good, very good. X to the third power. So that's the basic shape, and what have we done to it?
It shifted left 3 and up 2.
All right, so how should I write it?
Y equals parentheses x plus 3 to the third power plus 2.
Perfect. Nicely done. Does everybody see what he said? Any questions on this one? All right. Okay, you, 1, 2, 3, 4. So let's put you into groups. So I'm going to stop sharing this screen, and we will put you into groups. And each group will do a problem. And we will say that group 1 will do problem number E, group 2 will do problem number F, group 3 will do problem number G, and group 4 will do problem number H. So let me put you into groups, and then I'll come and talk to you. So we will say 4 groups. Start.
I don't think she. Wait, so number group 1 has F?
Yep.
Okay. So would the base function be x squared to n?
X squared. Yep. Base function will be x squared. Because it's a parabola. You're right, x to the 2n, but in this case, you can use x squared. You can use x squared. Does that help you to start with?
Yeah.
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 Okay. Alrighty. I'll go to the other group and see where they are at. All right. Which one are you doing?
We're doing G. Is it square root of -3?
Square root. Yeah, it's definitely square root function. And then did you say -3 on the outside? Yep, but it's all. And then also the square root is also flipped over, right?
Yeah, so before, right? No, like plus
so
4.
Say that again. Yeah, plus
Is it
4,
plus 4?
but it's not going in the same direction. It's sideways.
Is it negative x?
Yes, negative x.
Okay.
So it'll be
So
negative
square root of negative x plus 4?
plus 4, and then -3 on the outside.
Okay.
Perfect.
Okay.
All right, very
Thank you.
good. I'll go check on the other group.
Okay, keep going.
Mm-hmm. All right, how are you guys doing? Which one are you doing?
H.
And how did you do? What base function you starting with?
Is it x squared plus y squared?
Yep, equals 1. Good. And then what are you going to do? It's not done anything up and down, so sideways stretch. So how much sideways stretch is it?
It's
Is it
2, yeah. So it'll be x squared over 4 plus y squared equals 1.
Would you have to do over 4? Could you just do 2x squared?
If you do 2x squared, it will get shrunk half the size.
Oh, yeah.
Right?
Yep.
Mm-hmm. Okay, I'll go check.
X squared
X squared over 4, yeah.
Okay.
All right. Dan, can you check that? Alrighty. How are you guys doing here?
What problem are we supposed to be doing?
H.
Oh, okay.
So what base shape would you start out with?
X squared plus y squared equals 1.
Yeah, perfect. And then you can see up, down, it's 1, but left, right, it's stretched by a factor of 2. So it'll be x squared over 4 plus y squared equals 1. But then it's also shifted. It's gone left 2 and up 3. So figure out how to make that work. You would have to replace the x with what?
Oh, wait. Never mind. The letterings got mixed up, so we're on I then,
Oh,
because
I.
there's no E.
Oh, did I miss something?
Yeah, for number D, you put E right underneath it.
Oh, okay,
Without-
sorry.
yeah.
All right, so here, this is the one. Let me see if I can share my application screen. Can you see it?
Yeah.
Okay. So this one here.
Okay.
Are you okay with it?
Mm-hmm.
Okay, I'll go. So you said the base, oops. What did you put in place of the base function? You said x squared plus
y squared
equals 1. Okay, and now how are you going to change it for your new function here?
So x squared over 4.
Yeah, over 4. But then you have to change the x also because it's shifting. So it's going how many units to the left? The center has moved.
2.
2. And then the y has also shifted. It's gone up. So y minus what? 3? Yep, that will be your answer. All right, when I come back from the, when we come back together, you will share your answer, okay?
Okay.
All right. All right, breakout groups. All right. So hopefully you got the answers, and let's go back here. We'll start with group 4. Can you see my screen?
Nope.
Oh, okay, sorry, hold on. All right, can you see the screen now?
Oh yeah.
All right, so group 4 said x squared plus y squared equals 1 was their basic shape. It's stretched sideways by a factor of 2, so they put the 4 underneath because it's 2 squared. It shifted left 2, so that's why x plus 2, and up 3, so y minus 3. Questions on H? Is everybody okay with H?
I was just looking at the base function.
Yeah, the base function is x squared plus y squared equals 1. That's the basic circle. You okay with that?
Yes, ma'am.
Okay. All right. Who did this one? This one here.
G, right?
Yeah.
We got square root of negative x plus 4, and then minus 3.
Oh, sorry. I think.
Yeah, mine looks different. Yeah.
My numbers are off a little bit here. It's this one here. Wonder why my numbers
Oh,
are
okay.
off.
No, we didn't do that one.
Yeah, I know somebody
Yeah,
else did though. Who did that?
we did.
Okay, can you tell me what? So there's your base function, and what did you do for this?
X squared over 4 plus y squared equals 1.
All right, very good. Okay, the square root function. Who did the square root one?
We did.
Okay.
What, square root 1?
Yeah, this one.
Oh yeah. Yeah.
All right,
We
so that's the base function, and what did you do for your function here?
Negative x
Okay.
plus 4,
Plus 4
and then minus 3 on the outside.
minus 3 on the outside. Yep.
Yep.
Because 4 to the right, 3 down, and flipped over. Yep. Perfect.
Yeah.
All right, very good. Okay, who did this one here? What you start with? Base function is what? X squared.
Y equals X squared.
All right, y equals x squared. Okay. And then what did
we
you?
have negative X squared minus 4 on the inside plus
X
5.
minus 4 outside plus 5. All right, let's check that. 4 to the right and 1, 2, 3, 4, 5 up. Yep, you got it. You can always plug in a point and see if it works. So when I plug in 3, 3 minus 4 is 1, 1 squared is 1, negative 1 plus 5 is 4, and that matches your coordinates there. Oh, actually, does it? 0, 1, and 0. So 1 minus 4, negative 3 squared 9, negative 9 plus 5. Oh, yeah, so it doesn't quite give you the 0, 0. See how at 1 and 7 you have zeros? Can you see that? When you plug in x equals 1, you should get a 0. When you plug in 7, you should get a 0, which you're not getting here. So there must be some number outside here that you need to fix. What do you think? In order to get a 0, you should have a negative 5 as your output. So when you plug in 1, so let's get the text box from before and see what happens here. So let's take your function here. Oh, it's not letting me edit. All right, let's get a new text box. So you need to have some number in front, because right now the way you have it, if you plug in those numbers, you should get a 0. So if I plug in 1, look what I get currently. Tell me what you get if you solve that. Anyone? I'll get negative 1 minus 4 is negative 3 squared is 9. But instead of 9, you need to end up with a 5 to get a 0. Because you can see your coordinate here is 1, 0. Can you see on this graph? So what should we do here? Times what? So put a fraction. You want a 5 and you want to get rid of the 9. Can you see how now you'll get negative 5 plus 5, 0. And if you put 7 in, you'll also get 0. So now you have the right function. So put a 5/9. So you'll need a 5/9 out here. Please make sure you understand how this was done. So I'm plugging in. So if you look over here, can you see how? Let me get a. Make that point red. Can you see this point red that I just plotted here? 1, 0. Can you see? Yes, no, something? Hello? When I plug in 1, I need to get a 0. But right now, when I plug in 1, if there is no number out here, I'll get a 9. But I want to get rid of the 9 and have a 5 in its place. So that's why 5/9. Can you see? Hello?
Mm-hmm.
Not yet. Okay.
Can you see it now?
Yes, ma'am.
Okay. So the original answer people gave was it's moved 4 to the right and 5 up. That you can see just from this. And a negative in front makes it go upside down, right? Do you see that?
Yes.
Yes, but right now you also have a coordinate on there. 1, 0, and 7, 0 are points it has to go through. Right now, if I plug in 1, I will get 1 minus 4, which is -3. -3 squared is 9. -9 plus 5 will give me -4. This answer will be -4. Can you see? If I plug in 1 right now, I'll get -4. But I don't want -4. I want it to become 0, which means that this number has to be adjusted, that multiplier. The multiplier has to be such that you end up with -5 plus 5 will give me 0. The only way I'm going to get that is if I multiply the 9 by a 5 nines, because the 9 and 9 will cancel. Then I'll be left with -5 plus 5, which is 0, which is what I want.
Okay.
Can you see that?
Yes, ma'am.
Okay, so that's why that's the function. Any questions on that? All right. All right, let's move on to question number 3. So again, this is for the function below. You tell us what the graph of f of -x would look like, what this graph would look like, and so on. So we have, 3, 6, so we have 12 questions. So each group, so group 1 will do row 1, group 2 will do row 2, group 3 will do row 3, and group 4 will do row 4. You understand what to do? This is the original graph, and you have to tell us whether it moves left, right, up, down, flipped over, what happens to it. And you can redraw the second graph. So I want you to do this the way you will do when you come back. So one person in your group will be the group leader who will actually draw the graph in a Word file, or just take a picture of what work you do on the paper, and then you will present it to class. So you can hold it up, or you can tell me what to draw, and that's how you will present. So we're going to put you into groups of, so each row, group 1 is row 1, group 2 is row 2, and so on. And so you'll have 4 groups. So I'm going to put you into groups, and then I will come and check with each group. So go ahead and go into your groups.
Oh, sorry.
All right, you know you're doing the first row, right?
A, B, and C.
Yep, A, B, and C. You know what to do? Or do you want me to?
I did B. We just mimicked it essentially, but we mirrored it.
Mirrored it, yep. Which way? Left, right, or up, down?
Well, it's down.
Down. What about A?
A, that is to the left.
To the left, right mirror. Good. And what about C? Which way are you going to move? Which way?
Moving everything up to?
Up to and?
To the right 3.
Left 3. Yep. Left 3 is correct. Good, good. Okay, so finish drawing it and I'll come back. Well, you will share it with the class when we come back, okay?
Okay.
Won't that -x do something to it though too?
Chabangi, for
Yes.
D, would it be to the left 2, and then would it be up or down 3? That's what we're kind of stuck on.
Right, so the -3 does take it down 3. So that negative sign in front of the x. So here, maybe this will help you. Let me share my screen with you. Share. All right, can you see what I have?
Yeah.
So rewrite it like this. It'll be f of -x minus 2 minus 3. Does that help? Because then this is telling you x minus 2, so you're going to move it which way? 2 to the
right?
2 to the right? Yep, 2 to the right.
Wait.
And then also this negative will make it what?
A positive?
No, I won't make it positive. So actually, let's get your, so let me go here and get your
Isn't it
shape.
flip?
Yes, which way is it going to flip?
Oh, is it a reflection?
Yep, which way though?
To the left?
To the left, yep, you got it.
Okay.
So you're going to flip it to the left.
Mhm.
So 5, 6, 7, 8, like that. But also you're going to shift it from the 2 because it went right 2 and down 3.
Then down 3, right?
Yeah,
Okay.
so it'll be like that.
Okay.
Okay.
Thank you.
Uh-huh. Oh, right 2 you said, right? Right 2, down 3,
Yeah.
and then flip it. Like that.
Okay.
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 You're okay with the other 2?
No.
No? All right, this, so here's the original. Negative half. So negative means what? Outside negative means upside down flip.
Okay, okay. Alright.
And then half,
Oh.
so it will get, right now it's at 4, so it will get squished to 2. You see that?
Yeah.
Okay. And then this one, this is straightforward. This you can do, right? Up to left 3. Same shape. Are you okay with that?
Yep.
Yep.
Yeah.
Okay. All right, I'll go to the other group and see where they're at, okay?
Okay.
Okay. How are you guys
We kind of
doing?
need help.
Okay,
We
let's
kinda
see.
We're
need help.
Okay, you need help?
Yeah.
All right, let me share my screen. And you tell me when you see my screen. Do you see my screen?
We see it.
Yeah.
Yeah.
Okay. All right, what are you going to do with this negative x?
Flip it.
Flip it. Left, right?
Um. Yeah.
Yeah. And this negative will make it go
Up, down.
up, down. Very good.
No, down. Yeah, yeah,
Upside, yeah, it will go upside down, right?
yeah.
Okay, you got it.
Yeah.
What about this half?
We'll compress it.
Compress it. Very good. Twice as much. You got it. And what about this one? The y minus 2 will take it down to. So this, if you rewrite this as, this might help you. Does that help? Because that means it's going right 1, then you're going to flip it left, right, and then down 2. Or yeah, then you're going to go up 2 actually, because it's minus 2. You okay with that one? So let's draw that one together. So we have from here, oops. All right, insert shape. We'll go with the curve again. Oops, that's not working out. So we'll have to do straight line.
Yeah, this part for me is really confusing.
Yeah, I know. I'm going to make it red. Let's just get the graph here first. just a generic shape. It's hard to draw it here, but if we can draw it, then you can see it, I think. All right, so let's merge it together so that it's one piece. All right, so down y minus 2 will take it up 2. So 1 and 2. You okay with that part?
Yeah.
Yep.
Okay, then x plus 1. So what you're going to do to x plus 1, that means it shifts to the left one, so it will go there. You okay with that part?
Yeah.
Okay, so now once you have that part, whoops, sorry, I'm going to paste it and bring it back. So there's our original. We went, no, that's not ours. Ours is here. So there's your shape, but now negative means it reflects sideways. So it's going to reflect sideways like that from here. So it'll be more like this. Can you see?
Yeah.
So that's
Can
your
you
shape.
draw H2? Because I'm confused on how that looks.
H1, okay. So we'll take that shape.
He's an all of them.
You say H, right? This one?
Yeah.
So here's your shape,
Uh-huh.
and you're going to now, so this end, so shrink by 2. So 1, 2, 1, 2. So everything will shrink by 2. So it'll be like here. So instead of the 4, 0 will stay 4, 0. This will go to 1. Like that. All the coordinates, y coordinates got shrunk. It'll be like that. Can you see?
Yeah.
Yep. All right. So you draw the other one, and then I'll come back to you, okay?
Okay.
All right.
Yeah, I wouldn't have got that.
All right. How are you guys doing?
Doing all right yourself?
Good, good. You finished your problems?
Yeah.
Okay.
Yep.
All right. So we're going to go back together then, and you can share your work. All righty. We're all back together.
New class.
Hi.
All right.
Shut
Let's
up for
see.
one person who said hi back.
All right. Let's see. You tell me when you see my screen. Can you see my screen?
Yeah.
Okay. All right. Let's start with group 1. Tell us what you got. Group 1.
For A,
Yeah. What did you do for A?
for A, we mirrored the thingy to the left.
All right. Let me get my original shape to match yours. Oh boy. Okay, that's not working. We'll just draw it. That might be easier. You said take the original shape and do what with it?
We mirrored it to the left.
Mirrored it to the left. All right. So you went basically like that.
Yep.
Okay.
Yep.
All right. What happens to this graph here?
For that one, we just flip the whole thing upside down
Like that?
like that. Yeah, but then you gotta put the yeah, just like that.
Okay. Everybody okay with that? Yes, no?
Yep.
All right. Okay, what happened here? What'd you do here?
Moved it to the left 3 and then up 2.
Okay, 1, 2, 3, up 2. Everybody okay with that? These are good exam questions because it tests whether you really understand the concept. Any questions here? All right. Okay, next group. Oh, you have the same shape, so I can use this one. Somebody's cell phone is ringing. Okay.
Confiscate it.
Hey, give me your phone. I'm just kidding. Okay, now what? What you want to do? Here.
For D,
Yeah.
wouldn't it be down 3 and then over 2?
Down 3 and over 2 to the left or right?
Left.
Right 2. 1, 2. Right 2 because of this.
Okay. It's a
But then,
negative.
and then what about the negative? What will the negative do?
Wouldn't it? Yeah.
What's that?
Wouldn't it just flip?
Yep. Like that. Everybody see that? Any questions here? All right. And then negative half, it's upside down and squished halfway. So original shape was here, and everything shifted, got squished down to. Questions here? All right. Let's see. All right, this graph, what are you going to do to it?
To the left 3 and up 2.
Left 3, 1, whoops. 1, 2, 3, 1, 2. Yep, perfect. Any questions on that? All right. All right, what happens here? So it's the same shape, so I can take that and keep moving it. All right, anyone from that group? What should we do with it?
Do you reflect it over both axes?
Yes, so upside down. Oh my, it's not easy to rotate it just the right amount. All right, so, okay. And then rotate it. Oh, it's not letting me do that. Shoot. Okay, everybody understand what she's saying? I'll just have to redraw it.
I believe so.
It's going to go, actually, you know what? Here we may have to use the board, whiteboard. Let's see if we can get a whiteboard here. Stop sharing. There should be a blank whiteboard. Okay, so if this is a shape, the two negatives, when you flip this down, this will go, let's take a different color. This point here will go here, this point will go here, and this point will go here. So it'll be, can you see that? And then when you flip it again, huh? Did you say no?
Yeah, we can't see the screen, I think.
Oh, you can't see the screen? You can't see a whiteboard?
Yeah, I just see black.
Oh,
I can see the whiteboard.
All right, let's try again. What about now? Now can you see a whiteboard?
I see it.
No, but it's cool.
No, okay, hold on. I will figure out a way. Let's see. I will use the screen grab. All right, let's see. You tell me when you see my application screen.
Yep.
Yeah.
Do you see that?
Yeah.
Okay, so now let's grab a pencil. So this point is 1, 2, 3, 4. We'll go 1, 1, 2, 3, 4 here. And this will go to here, to here, to here. Can you see that? That's when it flips upside down. But now you also have to flip on top of it. You have to flip, let's see, pen. Let's do purple. So if you flip it left, right, this point, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 will go here. This will go down to, whoops, oh, shoot. Erase that. Yeah. Are you counting? Yeah. So this 0 will, 4, 0 will become negative 4, 0. Can you see? Then 2, negative 2 will become negative 2, 2. So you will go down here. Negative 2, 2 will go here. And then negative 5, 4 will become 5, 4. And that's how the shape would look if you flip it left, right. Can you see? Let's erase the red one. Eraser. So you can see. That's the final answer then. Upside down.
Why did we erase the other one?
Huh?
Why did we erase the other one?
The other one, because the other one was only half of it. The whole function is negative on the outside and negative on the inside. So this purple one is the entire graph. All transformations made to it. So flip upside down and reflect it sideways. Can you see? Yes, no, something?
I can see it, but 1, 2, 3.
So let's do another one because maybe that will help. So let's get a blank paper.
6.
Let me get a blank. Let me get a blank grid here. We'll use this grid here.
What number is this? That's number G.
The one we just did? The
Yes,
one
ma'am.
we just did was, yeah, it's G. All right, let's do. All right, let's do one here. So slideshow, get a pen. Everybody try this on your own. So let's say, oops, slideshow. Pen, here's pen. All right, let's say your graph is this. This is function g of x. Get me function g of negative x and then negative in front. So let me write it here. Keep and add. All right, g of negative x and a negative in front. All right, get me this graph. See what you can do. Can you see the graph here?
Yes.
This is g. Get me negative g of negative x. See what you can do. Tell me what to do. So let's do the negative x first. What happens when you have g of negative x? What should I do with this? Anyone?
Flip it to left.
Yeah. So it'll be like that. All right. And then what happens to, let me get a different color. We'll say green. All right, tell me what happens to this whole graph.
Would it flip down?
Yes. So we have 1, 2, 3, 1, 2, 3.
2, 3. Yeah.
Like that.
1.
Everybody see that?
Yep.
Yep. Any questions there? All right. All right, we'll save that in case we have to come back. All right. This next one here is half of g of x. So all the coordinates shrunk by half. So instead of -4, you'll have -2. Instead of -2 and 1. So actually, this we may have to do over here also. If you want to shrink it by half, all the coordinates shrunk by half. So this will go here. Oh, pen, red. So this coordinate here will go here. All the y coordinates shrunk by half. Instead of -2, 2, you'll be at -2, 1. Instead of 2 and 1, you'll be at 2 and 2 and 2, you'll be at 2 and 1. And 0 over 2 will remain 0. So your new graph will be from here to here to here. That's what happens when you shrink by half. The y coordinate shrunk by half. Everybody see that?
Let me see.
Yep. So instead of -4, you are at -2. And it should actually go through the 0 here. It will be like this.
2,
And then 2 will become 1.
2.
2 will become 1 here also. And the 0 will stay 0. Everybody see that? Questions here?
5, -5. Somewhere.
Yep. -5 is the x coordinate. And instead of -4 as being the y coordinate, -2 will be the y coordinate. You see that? Everyone see that? Yes, no, something?
Yes.
Yes? All right. So we'll say keep it in case we need it again. All right. And then this one. So let me move this piece out of the way for now. All right. So 2 up, 1 to the left. So 2 up. So that's the original shape. So 1, 2, 2 up, and 1 to the left. And then it got flipped. So instead of -6, -2, you'll have 6, -2, and that will be the shape. Do you see how it flipped left, right? Everybody okay with that?
Oh, it looks complicated. Can we simplify it a little bit, please?
Simplify it a little bit, yeah. All right, so first, the y minus 2 took it, so here's the original shape, right? Y minus 2 took it up to 1, 2.
2. Okay.
Okay, that took care of this part here. Let's make it red so we know we took care of that. You okay with that?
Yes.
Okay, then x plus 1. X plus 1 is taking it 1 to the right. Can you see that?
Yes, I did.
All right, so 1 to the right will be here. You okay with that? And
That's
we'll
my left. No?
say again?
It's my left. I took it to my left.
I mean, sorry, yes. Yes, 1 to the left. It's going
Okay.
1 to the left because of the x plus 1. Okay? And then once you have that, everything is going to reflect across the line x equals -1. So here is, let me get a line here so you can see how it reflects. So here's -1. I'm going to make that a little bit thicker. So that line is what I'm going to reflect across. So if I reflect across this line, tell me where this coordinate will go. Right now it's -6, -2, which is 5 away from -1. So you're going to go 1, 2, 3, 4, 5. So that's why it goes here. Can you see? Do you see that? It reflected. It's as if this black line is a mirror and the red graph got reflected across the black mirror. That's why it looks like that. Do you see that? Gold? Okay. All right. And let's see. Did we have anybody doing these?
Yeah.
Yep. All right. Tell us what to do.
The first one, you're gonna flip it over the axis.
Yeah. So
And then you're gonna move it.
I'm just going to write what they're saying so you can draw it. Flip. All right. Tell me flip what?
You
Across.
flip it over the y or the x-axis.
X-axis.
Then
Then
you go to the left 1 and down 2.
left 1, down 2. So on an exam, this is how you would write. You can write it in words. That way, even if your graph doesn't match, I know what you tried to do. Does that make sense to everyone? All right. What did you do here?
You have to take out you have to just take out to get that negative gone. So it's going to be negative of x plus 3 plus 1.
Yeah. All right. Negative.
So you're so then you're gonna flip it over the axis, right? Wait, no. You're just gonna put it upside down.
No, it won't be upside down. It will be flip left, right, but it will flip across x equals -3. So flip across x equals -3, left 3, and up 1, right?
Yeah.
Yeah. Everybody okay with that? Questions here? Do you want me to draw it, or are you okay?
I want to write that down.
Yeah. Flip across x equals -3, left 3, and up 1. It might help if people wrote it down like that, because then even if your graph didn't quite become correct, I will know what you tried to do. Does everyone know how to draw that? Or do you want me to do it? I can do it.
Can you please draw it?
Draw it? Okay. So let's take a little picture of this. Actually, let's take a picture of the whole thing so we know what the function was.
Okay.
And how do I get out of this? Right now it's in SciShow. It's stuck. Okay, hold on. Stop sharing. All right, tell me when you see the...
I see it.
Do you see it?
Yeah.
All right. Slideshow. All right, so up 1, left 3, and then flipped across x equals -3. So first, let's just draw. Let's see, we're going to get our pen. So here is x equal, so up 1. So all these points will go up 1, right? Actually, this is not helping. So hold on. We might have to go to Desmos because it's going to be hard to draw that unless I have a pen. Let's see. Tell me when you see Desmos screen.
Yeah.
So you have a graph, something like that, right? F of x. If you have this kind of graph, let me just go check and see what the graph was. 2.
Wait, wouldn't it flip over -4 because of the asymptote?
Yeah, no, I'm just getting the original graph. This is my L of x or whatever that function was. And now you're saying L of negative parentheses x plus 3 plus 2. Do you see how it flipped over? This way? Can you see? And let's do one piece at a time. So first, up to. Everybody see going up to? Okay. Then we add x plus 3 plus 2. Do you see how it shifted left 3?
Shifted left. Okay. 1, 2, 3.
Oh, oops, 2. Do you see how it shifted up 2 and left 3? Everybody okay with that? And now when I put a negative in front, do you see how it flipped across the line x equals -3?
Yeah.
Do you see how it flipped over? So let's get rid of this one and this one. So the purple graph is a reflection of the green graph across the line x equals -3. Can you see that? Yes, no?
Yes, we see the.
Yeah, so that's how the graph will look.
So then does the point on -3 stay there, except it's
Yeah, the point. So the -3, the line is just, this line is just telling you what it's reflecting across. That's correct. You're talking about this point here? Yeah, this point stays.
Never mind. Yeah, never mind. I got it.
You okay with that?
Okay.
Yep. Any questions here? All right. Let's go back to our thing here. What happens here? Oh, this is an easy one then. Upside down, right? This one? Okay. All right. Is that the end of that section? Let's just make sure. Is that the end? Is that the last question?
No, there's a whole other page.
Oh, yeah, yeah. This?
Damn.
All right. So 4 says you are given 2 graphs and you tell us how they relate to each other. How do you think they relate? First of all, f of x is going to, what's happened to f of x? To get g of x, that's what they're asking. What do you think? We can say g of x equals, all right, negative. So flip and then what? Hello? And what, how much to the left or right? Right, how much? And then plus what? 5, yeah.
Yes, I can.
So upside down, right? So that's why the negative in front. You also went 6 this way and 5 up. Questions here? Any questions here? Okay. Yes, no?
No.
Okay. All right. Here they're saying you have electricity consumption over a 1-day period for a household is given by that function. Total electricity if 2 other households 1.5 and 0.5. Well, what are you going to do with the graph if you have 1.5? All these points will become times 1.5, so it will be here. So actually, we're going to have to draw this out. So let's get a picture of that. All right, let's see who can tell me what to draw. Can everybody see it?
Yes, we can, man.
Okay.
Yeah.
All right, so 1.5, that means 1 times 1.5. So this point will be here. Oops, sorry. I don't know how to get the, where's my pen here?
6 differences of increasing numbers. 6.
So you're multiplying by 1.5, so it'll be here to here. 3 times 1.5. How much is 3 times 1.5? Somebody tell me. 4.5?
Correct.
And then it will go down here again and down here. You understand it's the basic shape. I just couldn't draw it with a mouse. You see it?
Yeah.
Okay. And then 0.5. 0.5 means that this point will go here. This point will go here. Half of 3 would be 1.5. And 1.5. And 1/2. And so your graph will be, oh, that was much better drawing. Everybody see that? Okay. What does that mean? That means that the electric consumption for the graph that's 1.5 times the original means that household spends 1.5 more energy than the other house. And the 0.5 times the household means they have half the electric consumption compared to the other graph. Everybody understand what it means? Who can explain the shape of the graph? Why do you think from hours 0 to 12, it's a flat line? And then there's a spike.
They were sleeping.
Yes, very good. Very good. Yep, or at a job or something. Yep. Okay, good, good. All right, let's see. Is that the end of it? Is that the last one?
There's extra credit. It says extra credit.
Oh yeah, well that's extra credit, so you do that. You can use Desmos for extra credit and see what happens. Okay? Yeah, there's lots of extra credit questions here, so if you want to try that out on your own, try it. See what happens. All right, let's go to class 16. Are there any questions on class worksheet 16? Any questions on class 16?
Did you get my email from earlier?
Yes, and I sent you another email back.
Oh, I probably should look at it.
So
Okay.
if you can print it, and this is for everyone. If you can't print a file, that's okay. You can handwrite it and then just take a photo of that. That's fine. You don't have to print it. Any questions on this worksheet, home worksheet 16? Anything at all? This was an easier one because if you already knew how to factor, you didn't even have to watch the video. But if you can't factor, then you may want to watch the video. Who had a question? Yes, ask away.
Can you go over 15?
Yeah. Which one? 16?
15.
15. Oh yeah, determine how to reorganize the quadratic to complete squares so that it's in this format. All right, so I'm going to open here to write here. And let's see. Can you read me the polynomial, the first one? So this is 15a. Can you read the polynomial?
2x squared
Okay.
minus 4x plus 1.
So completing the square means you cannot have a number in front. So you have to factor the 2 out. So it will be 2 times x squared minus 2x. Then leave a little space. And then add. So do you remember how to complete squares? You take the middle number, which is in this case 2, divide it by 2, and then take the 1 and square it and add that number here. So that'll be 1 squared. That's what you want to add. What is 1 squared the same as? That's the same as 1, right? But if you add a 1, what you're really adding is 2 times 1. So this will become minus 2 plus 1. Why? Because 2 times plus 1 is plus 2. And if I minus 2, that's like saying add a 2 minus 2. This is really just 0, so it didn't really change my original problem. Can you see that? Molly, can you see that?
Yeah.
Yep. And so now I have the completing the square part. So this part here is a completing the square. So this will become 2 times x minus 1 squared. Negative 2 plus 1 is negative 1. Are you okay with the process of completing the square, or should I go over that first?
Yeah, can you go over that?
Okay, let's go over that. So completing the square literally means completing the square. So for example, let's see. Let's get a blank sheet here. All right, completing the squares. So if you're completing the squares and I said, let's do x squared plus 6x. And I ask you, I want to complete the square. What the heck does it even mean? So what I want you to look at, let me just get the, so if you look at x squared, if you wanted to visualize it, you can visualize it as a square. Why is that a square? Because x times x is x squared. Can you see that? Yeah. So this is the area of this square is x squared plus 6x's. So I'm going to take that shape and I'm going to go here, but the width is 1. So let's make that a different color so that we can see. So we have 6 of those. So 1, so here's 1, 2. So there are 6 of those, and so let's just put them here. What shape do you see right now? Like just this, all the way across. You have x squared, 1x, 2x, 3x, 4x, 5x, 6x. It's a rectangle, isn't it? Can you see the rectangle, everybody?
Yeah.
Yeah. So I want to make it a square, though, because they say, could you make a square out of it? Well, how can I make a square out of it? I would have to take these and turn them, because the only place they can go is here. So tell me how many of these I should take and turn and put them here so that I end up with a square.
1, 2, 3.
3. 1, 2, 3, 1, 2, 3, she says. So 1, 2, 3, 1, 2, 3. So basically, whatever amount I had, I took half of them. Can you see how I took half of these and put them sideways here? Can you see? Now I have a chance of making that a square. How? But I would have to add something. I would have to add something here to make it a square, isn't it? Let's make that red. How many such pieces would I have to add here to make a square then? Who can tell me what I should add?
9.
How many?
9 of them.
9 of them.
2 of 9.
Yeah, because look, that's 1, that's 2, that's 3.
3.
But now it's not a square though, is it? Don't I need more pieces to fill in the space here?
Yeah, but it's half of 1 bar.
Yes, yes, but I needed 9 pieces to make a complete square. I needed to fill in that whole bottom area, right? See, now it's a square. Can you see? So I had to add 9 to make a perfect square. The way I got that 9 is I took half of 6. I took half of 6, and then I squared it.
Can't you solve that by doing that factoring x?
Factoring x, but then it won't give you a it will give you a rectangle, but it won't give you a square, right? We needed to know what to add to make a square.
Okay, gotcha.
So that's why you take whatever this number is, take half of it and square it, and that will give me a perfect square. It's x plus 3 squared. Can you see why it's x plus 3? It's from here to here, it's x, and then 1, 2, 3. X plus 3 times x plus 3 is x plus 3 squared. Can you see? Molly, does that help? For completing the squares? So anytime you want to complete square, the x coordinate here, the number that sits in front of x has to be just 1. Because if there is not 1, we can't complete squares. So now if you go back to your problem, which is over here, this is your problem. So we have the 2 in front of the x squared, so we cannot complete squares. So we would have to pull the 2 out. Once you pull the 2 out, we have 2x, the 2 from here and 2 from here. So x squared minus 2x. Now we have to decide what to add here. So remember, we said add half of the negative 2, half of negative 2, and square it. That's how I got negative 1 squared. This whole thing will give me a 1. But look at what I am actually adding. I am adding 2 times a plus 1. So then I have to compensate for it and subtract the 2 so I don't change the original problem. So the original problem is still what I started with. And then this inside here is a perfect square of x minus 1 squared. And then the negative 2 plus 1 gave me the negative 1. This allows you now to see why this completing the square is useful, because I would now know how to sketch the graph of this quadratic function. Can you see? What shape will it be, do you think? So I'm going to take this and go back to our original problem. So over here then. So that's our problem. Do you see how it's in that form? Our A is 2, our H is 1, and the K is 1. So if I said, do you think you could sketch the graph of this? What would the graph look like, do you think? Do you think you could sketch the graph of the function y equals 2 times x minus 1 squared minus 1? What do you think the graph would look like? Let's get a blank graph paper from up here, from our other file. All right, tell me what I should graph. What shape is the basic shape? It's a parabola shape. Parabola. So we will have 3 and 9, 2 and negative 2 and 4, 0, 0, 2, 4, and 3, 9. So that's our basic shape. What should we do with the x minus 1 squared? So where should we move it?
Right.
Right what? Right 1 and down 1.
Down.
And then the stretch of a factor of 2. Can you see? Do you see why we're completing the squares? It's going to help us graph parabolas, basically. All right, let's see. Let's do another one just so we can see. Can you read the next one, 15b? Molly, can you read the next one?
3x squared plus 12x minus 5.
All right, tell me what to do next. So factor the 3 out first. So we'll have x squared. Somebody give me what I should put in the bracket here then. Plus what?
Plus 4.
Plus 4x.
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 All right, now tell me what to add here to complete square. Half of what? Half of
2,
that.
2.
Yes, that's right. Very good. So 4 over 2, which is 2. And what's 4 over 2 the same as? Hello? 4 over 2? Oh, come on.
It's 2.
It's 2.
Yeah.
And 2 squared. How much will that be? 2 squared.
Times 2.
2 times
4.
2, 4.
4.
All right. So we're going to add 3 times plus 4, which is 12. So we have to compensate. And so instead of adding, we have to subtract 12. Can you see? All right. So final answer would be 3 times x plus 2 bracket squared minus 17. You see that? Is there more? Let's see. There's 2 more. So let's see if we can do those quick. All right. Can you read 15c? Negative x squared. What? Anyone?
Plus 4x,
Plus 4x.
minus 2.
Okay. All right. Go ahead. Complete squares. So this time you just have to pull out negative 1. So it'll be x squared minus 4x. All right, tell me what to add here. What should we add? Half of negative 4, which is negative 2 squared. So 4. But this time it's -1 times +4, which is a -4. So we have to add a 4 to compensate. Can everybody see that? Yes, no? Something? Any difficulties right here? All right. So it'll be -1 times x minus 2 squared plus 4 minus 2 will give you +2. There's one more. Is there one more or is that last one?
There's one more.
All right. Go ahead. Tell me what the last one is.
-5x squared plus 10x minus 4.
All right. So it'll be -5 parentheses x squared minus 2x. All right. What should we add? Half of -2, which is -1, squared is 1. -5 times 1 is -5, so you have to add 5. So this will become -5 times x minus 1 squared plus 1. Questions here? Everybody okay with this? Questions here? Okay. All right. Any other questions in 16 homework? Oh, I guess that's the end.
I didn't see the last. Let's see the last part of 15D, please.
This one? 15D, you said?
Okay. I have it.
Is that?
Thank you.
Okay. Any other questions on home 16?
16.
No, everything else is okay? All right. So class 16 is what we will do next class. And so I'm only asking you to look at class 16. And if you can go to home 17, that will be good. So home 17 and look at class 16 because it's similar to the questions that we were doing here. Everybody okay with that for homework? Yes?
Yep.
All right, I'm going to stop sharing. I have one more poll question for you to answer right before you leave. All right. All right, if you need help on class 16 or class 15, you can stay now for office hours, or you can make an appointment with me so I can work with you one-on-one. And we'll continue with class 16 for next class, and you will look at home 17, if that's okay with you guys. Everybody okay with that? All right.
Yeah.
Okay, thank you. Hi, Josh. You have a question?
Are you able to meet tomorrow or no?
Yep, I can meet tomorrow. What time would you like to meet?
Around like 1?
Around 1?
Okay.
Yep, that will work. I can
Okay,
send you.
I'll just email you.
So say again? At 1
I'll
o'clock?
email you. Yeah.
Okay.
Yeah.
All right, that sounds good. I can help you one-on. Somebody, if anybody else wants to meet with me 1 o'clock tomorrow, just let me know. Gold? What did you say?
Mine is noon tomorrow.
Tomorrow at noon. I actually have a meeting tomorrow at noon, but I can do before or after.
Okay, before.
Before, okay.
What time?
You wanna do it at 11?
Okay.
Okay, tomorrow at 11 then for gold. Okay.
I want to meet with you for 15 as well. This one?
For 15. Okay, sure. Yep, no problem. We can work on that.
Okay.
If you want to stay now, you can. Otherwise, we can work tomorrow at 11.
I can stay now and I can stay 11, maybe for the next sheets.
Okay, sure.
16.
Sure.
Okay.
Okay.
I'll probably meet with you tomorrow.
Tomorrow at 11?
Maybe 11 or 1. I don't know yet.
Which one?
Can I email you?
Yep, you can email me. Then I'll send you the link.
Okay. All right.
Can
Okay.
I come in for both?
You surely can.
And then, okay, cool.
So
You said you're
I'll
gonna be gone at
send.
noon?
Yeah, so I have a meeting at noon, but I can meet before or after, and I can stay as long as you want.
Okay.
So you can come at 11, then again at 1, and I'll send 2 different links for that.
Are those okay? Because those aren't going to be the same link for the one that we get to for this class, right? It's going to be a completely separate link.
Right. It will be a separate link because there may be because it's not necessarily going to be a collaborate one. I can do a Zoom because then we can see each other. Might be a little easier. I don't know. We can try a Zoom and see.
That's the app, right?
Zoom is an app, or I can set it up here. Either way, do you like this? This is okay, right?
I mean, this seems to work fine, but if you want to do it
Yeah.
the other way,
Nope. I can do it this way, and then I can just send it to the whole class and see who wants to come. So 11 and 1 tomorrow. Right? Then you can come to both or one, and you don't have to stay the whole time. You can stay as long as you need to.
Okay.
Okay.
See you tomorrow.
All right. Sounds good.
Okay, cool.
Okay,
Sounds
Gold.
good.
You're staying now also, or you're just coming tomorrow?
I'm staying now and tomorrow.
Oh, okay. All right. Sounds good.
Okay. Number 8.
Number
I didn't
8.
see the question for
All right.
number 8.
You tell me which in which 8 in which one?
Oh, okay. It's the class.
Class.
The class worksheet number.
But which one? 15 or 16?
Oh, hold on. Oh, it's 15.
All right, 15.
Number H.
H. This one?
No, the other one. The one at the back. Let me see. Number 2.
Oh, number 2. 2H. Okay. So this is 1. This is 2. 2H. This one here?
Let me see. That's it.
This one here?
Yes, ma'am.
Okay. So the base function was x squared plus y squared equals 1. And if you look at the base,
Is this one next to your H? Your H is my I.
Oh, okay. I think that's because I was entering things. This one here?
That's it. G is for you is G.
Yeah.
Mine is H.
I know that's because I was entering things and things got messed up. So x squared plus y squared equals 1. And if you look, that's a circle of radius 1. And this, you can see the vertical direction is still 1, -1. But the left, right got extended by a factor of 2. Can you see that? Or 4 in this case.
Let me see. Are they equal?
Yeah, they're equal.
Okay, this is.
So actually, this should be 16.
That's 4 and -4, right?
4 and -4, yep. So actually, we have to correct that from class. We had 4 down here, but it should be 16 because it's 4 and -4, right? And 4 squared is 16. So this is x squared over 16.
See that?
Yeah. I'm glad you asked that. We should make sure we correct it in class tomorrow.
Okay, on Thursday.
Oh, yeah, Thursday, not tomorrow. Yeah.
Correct.
So actually, this one here will also be 16 then. Yeah. Okay. Do you see that?
Yes, I did.
Okay.
16, yeah.
Mm-hmm.
Okay.
Okay.
Now, this number 3, we didn't finish number 3M.
M. All right, these?
Yes.
Okay.
What happened, though?
All right.
See?
What do you think we should do? It's the same thing though, right? So tell me what to do.
Like the 3 of them are the same, but me, I can say now that this is plus 2, it will go up, 2 up, and then 3 down, or 3 to the sides for M.
Yeah. I'm just making it bigger so you can see. All right, what did you say we should do? 3.
Okay, plus 2.
So left 2, 1, and down 3.
And down 3, yeah, that's what I said.
Yep, you got it. What about here?
And then down 3. And then this one.
Up 2. Well, first, actually, it's going to flip over.
Why?
Because of upside down, the negative on the front.
Negative, okay.
So it will flip upside down.
Because of the negative. Because writing myself down because of.
And then up 2. 1, 2. You okay with that?
Okay, let me see. Did you say it will go left? You said 2?
No, up 2.
First?
No, you have to flip it first because order of operations. Negative first.
Okay.
And then plus 2.
First. Then up 2.
Yep.
Okay.
1, 2. You okay with that?
Yes.
Okay. What happens in this next one? X minus 1, so
Minus 1 should go down.
nope, it's X minus 1.
Okay.
If it's minus 1 on the outside, it will go down 1. This will go right 1. And then when it's 2 times, all the points get multiplied, y coordinates get multiplied by 2. So tell me what to draw. Right now you are at 3, negative 1. So now you'll be 3, negative 2 instead of 0. Yeah, so you just have to multiply each of the y coordinates by 2 and draw it. So you finish that one. All right, tell me what to do here.
Okay.
We should actually do these in class so that I can make sure. Yeah. Can you ask? Yeah, ask me these in class so that we can draw them in class. Because we need to do these, especially the S, T, and U. Okay? So let's just save this for now.